this is King of Review. Here we have a logarithmic inequality. Now one issue right away is that there's a 2 sitting in front of one of our logs. We can fix that by remembering that if we have a number a times a log base b of x, we can move the a inside the log as an exponent on the x we already had. If we apply that in our inequality, we have the log base 1/3 of x minus 2. Oops, sorry, it's not equal, it's greater than the log base 1/3 of x minus 4 squared. Just moving the 2 inside the log as an exponent. Now let's expand out the right side. We have the log base 1/3 of x minus 2 is greater than the log base 1/3 of, if I distribute x minus 4 times another x minus 4, I get x squared minus 8x plus 16. I'd love to be able to get rid of these two logs since they have the same base, and we can easily do that by remembering that logs and exponents are inverses. If I take some number b and raise it to the power log base b of x, the exponent and log cancel each other out and we're just left with x. So I'm going to raise 1/3 to the power of both sides. The only issue is that 1/3 is less than 1. I know the left side of my inequality is greater than the right side, and if I raise a number less than 1 to a bigger power, I get a smaller number. So my sign is going to switch, and the 1/3 and log base 1/3 cancel each other out. If I move the x minus 2 to the other side, subtract x and add 2, I get 0 is less than x squared minus 9x plus 18. I'd like to switch these around so that my x's are on the left side of the inequality, and if I switch around an inequality, the less than turns into a greater than. I'd love it if the left side can factor, and if it factors, I should be able to find two numbers that go in these parentheses that multiply to 18 and add up to -9, and those numbers are -6 and -3. So this tells me two things. One of two things must be true. If this product is greater than 0, either both factors have to be greater than 0, positive times a positive is a positive, or both factors have to be less than 0, a negative times a negative is also positive. If I solve the two equations, the two inequalities, on the left I get x is greater than 6 and x is greater than 3, but of course if x is greater than 6, x is automatically greater than 3. On the right side, I have x is less than 6 and x is less than 3, but of course if x is less than 3, x is automatically less than 6. So I have two possible answers, but there's a problem. I have to remember, whatever x is, it gets plugged into a log. One of these logs subtracts 4. I have the log base 1/3 of x minus 4. Whatever number goes into a log has to be greater than 0. If I take a number less than 3 and subtract 4 from it, I will not have a number that is still greater than 0. So x is less than 3 is not possible. I need a number greater than 6, so that if I subtract 4 or subtract 2, it will still be a positive number. So x is greater than 6 is my only possible solution. Thanks for watching.